always hear from customers from any shape or size, from any industry, is around the idea of migrating to a public cloud, yet not taking any risk to their existing on-premise businesses. Oftentimes, the customers are tied into this whole dilemma as how they can go enable their IT operations in a public cloud by taking the cloud adoption journey, yet at the same time not willing to take risks or move into a public cloud with any sort of disruptions. This is exactly the same problem that Google has thought through, and Google has come up with a product called Google Cloud VMware Engine, or also known as GCVE. My purpose for this call today, or this demo today, is basically to walk you on a very high level about what GCVE is, what sort of problems the customers are facing, and how GCVE sits in the perfect sweet spot in helping the customers to move to public cloud with taking most efficient approach in terms of risk, the least risk that they can take in terms of migrating from on-premise to something like Google Cloud. I want to quickly dive into this next slide, which actually hits the nail in the head when we talk about how the customers feel on their on-premise environment today. So if you look at the options that Google has on the table today, you might be wondering, what are these options all about and which one is the best fit for me? I think the best way to look at this particular slide is to understand where your customer is today and where do you want to be in future. On the extreme bottom left, you do see an environment which is very less complex, and this is more close to how you're running your on-premise environments today. You might be using open source technology like OpenStack, or you might be using VMware software-defined data center technologies to manage and orchestrate your virtual machines. No matter which customer do we talk to, every single one of them has a 5-year or 6-year plan in terms of moving to public cloud, being cloud native, making more microservices, distributed nature applications, which is where Google has different product offerings. However, the reality is that none of the C-suites, none of the IT enterprise leadership is willing to take any risk on their existing on-premise nature of business. This is where lift and shift is oftentimes a common choice for customers to take as a first step. And this is exactly what Google Cloud VMware Engine is solving for customers. A perfect use case is a customer running a VMware workloads on-premise environment, and they want to move to Google Cloud to benefit from the Google ecosystem. However, they are not willing to modernize their applications. They want to just lift off their applications as is and move them into public cloud. This is exactly what GCVE is solving for. We know that the customers may have multiple reasons. The most common 4 reasons that I can think of is on this slide, but by no means these are the only 4 options. It could be running and operating in a DR methodology, taking backups, moving towards more app-driven mentality or mindset, or building an environment with just for the VDI setup. It could be one reason or the other. Most common use cases for VMware Engine are basically these 4 common use cases that we have seen across different customers. When we talk about the private cloud, and I'm going to be very high level on GCVE product itself, but when we talk about GCVE product, it's basically a VMware as an engine service where you get the products like VMware NSX controllers, VMware vCenters, 3 ESXi nodes at the minimum, and you get the whole vSAN architecture around it for you to leverage and host your workloads in a VMware environment. A typical architecture for customers would be defined in this slide, where we have an on-premise environment, which is again, a customer is leveraging VMware Center for managing and orchestration their workloads. And then you can spin up a similar environment in GCVE. And in the case of the customer want to operate in a hybrid state, you will have to connect the 2 environments. And when you talk about Google Cloud, the 2 most common options are either connecting over the internet using Cloud VPN, which is basically IPsec tunnel between the 2 environments, or by leveraging by moving the traffic on a fiber. That fiber can be managed by Google or by Google partners, namely named as Google Cloud Interconnect, which is dedicated interconnect, or partner interconnect. The most common question is why the customers want to move the VMs. We want to be cloud native, we want to be agile, but then why do we want to get rid of the VMs on premise and still want to move them to public cloud? Well, as I mentioned, there are many use cases in terms of minimizing the risk, and the customers will always look at lift and shift as one way to move towards the public cloud. There can be many reasons in terms of making sure that you're moving your workloads from on-premise to public cloud, and some of them are always boiling down to these three common type of migration methodologies. I'd really like to discuss the migration methodologies in terms of how much complex the migration is going to look like, and what is the experience like. Is it more cold migration, warm, or hot? The fundamental distinction between the three is all around the downtime and how the data gets copied over. With cold migration, we're looking at static content. We're looking at transfers like VMDK transfers. The idea is that your virtual machine is going to be powered off, data is going to be copied over, and your VM machine is going to power up. In the event of warm migration, you do have a downtime, but basically your data is copied over while the machine is operational. But what happens in the case when your application cannot afford a downtime? Well, this is exactly what hot migration is all about. Your VMs are going to be migrated from on-premise to GCVE with no downtime. So you'll have a hot migration with no packet loss. If you look at the GCVE technologies, or inherently VMware technologies, there are basically two high-level migration technologies. There is a vMotion and there's a replication. What I want to do today is I want to quickly walk you over the ideas behind the vMotion technology, the migration technology, and then how GCVE, in which we have a product called HCX, is basically going to help you in terms of extending your network, in terms of helping your application, in terms of helping you perform your migrations using something called HCX vMotion or HCX bulk migration. There are some prerequisites, as any solution does have, for making sure that the migration is happening at a more efficiency and with no packet drops. So there are some bandwidth and some latency requirements, which we have highlighted here on this slide. When you spin up a GCV environment off the box, you do get two license offerings. There's an advanced license offerings, and in certain use cases, you are entitled to upgrade the license at no cost to H6 Enterprise. But the idea is that you do get the cold vMotion and bulk migration options right off the bat when you spin up the GCV cloud. This is a slide which is basically a very high-level slide in terms of enabling HCX as a solution. So I'm going to skip this for now, and I'm going to walk you with the demo. And you heard it right. Is there any better way to understand the technology or experience other than watching a demo? And that's exactly the purpose. I want to make sure that we run the demo and we cover certain use cases that are important. I'm really excited that I was able to set up a topology, which was possible just because Google and Sada are always making choices to make sure that the customers are way more comfortable in understanding as to what the experience is going to look like. So shout out to Google plus Sada for helping me spin up those credits so that I can spin up the GCV environment, and Sada to help me facilitate this demo environment so that I can make it much more easier for the audience to understand what sort of migration technologies are out there. So what you see in this environment slide is basically I have a GCVE environment running in my project in Google. I have a hub and spoke methodology. I've got a hub project with global scope VPC, and I've got two spokes. What you see on the top left is basically a prod demo GCV cloud, and I've got non-prod. So this is more a replica of environments where customers may have a production environment and a non-production environment, and it's connected to a hub and spoke methodology. On the right side, I have an on-premise environment, and the idea is that I have an Active Directory, I have a DNS server, I've got a bunch of vCenters running and a collection of VMs. The idea is to replicate this environment close to how an IT enterprise is set up. I've got an edge firewall, which is establishing a cloud VPN with GCVE. So in this case, my subnet 192.168.68, which is my home LAN, is now extended all the way across to GCV environments so that I can perform the migrations across the two environments. I can skip this slide. This is just the CIDR planning, which is something that you need as a homework to spin up your environments. And without further ado, I want to quickly dive into 5 demo use cases. The first 2 demos, the demo 1 and demo 2, is for the audience who is not familiar with VMware. So for anyone who has fairly worked on VMware extensively, would want to skip the video and dump into the demo 3, because the first 2 demos are local within VMware environment, and this is more specific to the users or audiences who are not familiar with VMware. So in 1 and 2, what I'm going to be doing is I'm going to be quickly running 2 demo use cases, which are more specific to 2 vCenters. not about Google Cloud, but for demo 3, 4, and 5, I want to build on to what I've done in 1 or 2 to continue with how would you do it similarly as you do it in demo 1, 2, when you look at the migration methodologies between on-premise and GCP. The first demo is basically a cross-center vMotion. The high-level idea is that you have two vCenters, and you have a virtual machine, and you want to do a vMotion between the two vCenters. So let me take you really quickly into my environments. So I've got this vCenter set up. This is my home lab. I've got vCenter1, homelab.internal. That's the domain that I'm using on premise. I've got one data center with one host in it, and it has some virtual machines running on it. The other environment is VC2, and you might be familiar that a single pane of management glass is possible when you use something called link mode. So I'm using link mode in terms of vCenter 1 and vCenter 2 managed through a single platform. On the right in this tab, I have a similar environment running in Google Cloud. So I'll get to this in a short while, but basically you get the idea that the interface and the experience is exactly the same. Google has made sure that the customers who are migrating to Google Cloud do not find too much of complexity around the whole process. So this is where GCPE VMware is pretty straightforward as to how anyone would be operating their vCenters on premise. So without a further ado, let's dive into the first demo use case. So I've got first data center hosted on my hosts 192.168.60 at 151, and I have another vCenter running with two hosts, 152 and 153. What I want to do now is I want to perform a vMotion migration of a workload from one vCenter to another. So my first pod is a demo 1 pod, cross-center vMotion pod. And if I quickly want to access this VM, so you'll see that this is a small VM. It's a tiny Linux virtual machine environment. And let me quickly log into this VM. And if I want to show you, so basically this is a small VM with one NIC with an IP address 192.168.168.223 and a MAC address of DCAD. What I want to show you is basically the idea as how you can migrate the VM in one vCenter to another without any packet loss. So I'm running a constant ping on my vMotion, on my virtual machine, which is running in vCenter 1. What I'm going to do now is I'm going to perform a vMotion migration. And what we will see is that once we click on the migrate word, it asks you through a very self-descriptive step-by-step process. So in this page, it asks you about the migration methodology. Do you want to move the compute resources, storage, or both? So I'm going to select both in this case, and we'll press next. This is more destination host. So as I said, I want to move them to a cluster 152, cluster local and the host 152. This is more around what's the virtual disk format. So I'm going to select trend provisioning. And then you can select the VMs that are candidate to move to a certain folder hierarchy. So I can keep this as is. It's a warning message around the VM network. And the idea behind that is the network tied to a VM has a scope, which is vCenter scope. So it's just giving a warning message saying that if you move this VM to another site, the chances are that you may lose the network connectivity. But in this case, I'm sharing the network with both the vCenters, so we can ignore this. The idea behind these two is to schedule the vMotion, or you do it at a high priority at the same time. So I'm going to do this at a higher priority. And when you hit the finish button, it gives you a summary of what configuration you're choosing from. So if I press the finish button, what you'll see immediately here is a very quick, fast process of the VMs migrating over from one vCenter to another. So if I go to my demo pod, I do have lost the connectivity, but that's only the serial connection to that pod. It's not the VM itself. So you can see that the D1 pod is moved over to D1 pod's cross-center vMotion into a host 152. And if I want to quickly see the traffic going through this VM, what we see is that the traffic is still going through. So if I stop the ping, I see 0% packet loss. This is extremely powerful. This technology has been there for the very longest time, and customers have leveraged the vMotion among the vCenters for a very, very long time. So this is, again, something very basic, might be new for many people who are not familiar with VMware. With that, I want to go to my second demo. The second demo is about SRM. which is Site Recovery Manager or vSphere replication. The idea behind this kind of migration methodology is that you have a site 1 and you have a site 2, site 1 being a source site, site 2 being a destination site. And the idea is that if you have critical VMs running on site 1, you want to configure SRM, which is a tool that I'm going to walk you over, and make sure that your site 1 VMs are always protected. That means that there is always a replication happening between site 1 and site 2. And in any unlikely event of site 1 completely going down, it could be power outage, it could be collapse, it could be catastrophe, but you're not losing your VMs. Your VM are always protected. So that means that your data center 2 or the site 2, which is the target site, is always willing to spin up the same VM from the latest copy of the source. So the idea is that you basically install an appliance on site 1, you install the appliance on site 2, and you perform something called SRM, Site Recovery Manager, by vSphere replication. So without further ado, as I said, you have to install an appliance. So you see that I have a replication appliance installed on site 1, which is remote. And I've got another replication appliance installed on site 2, which I'm calling local. But the moment you do this, the moment you install these appliances, there's a plugin that gets installed into vCenter. You have to log out, log in again, and then menu will show you something which is known as site recovery. Once you click on the site recovery, you'll see a status of Site Recovery Manager between vCenter 1 and vCenter 2. As you can see, my vSphere application status is OK on VC1 and VC2. So I'm going to click OK. It's going to show me the vCenter 1 page. And now what you see here is that I had to establish a site pairing. So you establish a site pairing between the two vCenters, and then you can configure something called replications. So when you click on that page, you see this small tab on the top right. When you click on it, it talks to you about the replication and you define the direction. In this case, my use case is that I'm going to be picking a VM in the site 1, let's say tiny VM SRM. So that's the VM that I'm picking as a candidate. And I want to make sure that it's protected all the time. In the event, if my VM goes down, I have a replication established. So I have this VM D2, which I do not have in the vCenter 2. So if I go to site recovery, I want to create a replication in the outget direction, which is from VC1 to VC2. So I would have to hit the button create. I have to select the candidate VM that I want to protect. You can protect more than one, but in this case, I want to protect one VM. Hit the next button. I can hit the next button. And in this case, if I go and if I have to select, I can select the destination data store, because once the VM is protected, we want to define as to how the destination data store is going to be like. This page is all about replication settings. This is where you define your RPO, RTO. And the idea is that you want to make sure how quickly your data is getting replicated, what's your recovery point of objective, what's your recovery time of objective, and that's the whole settings that you would establish for your disaster recovery strategy. So I can afford to drop it down to 5 minutes just because it's a test environment. You may want to tweak those numbers depending upon how you are taking backups, the nature of application, the criticality of the traffic. So once I hit the next button, a summary page, and I can hit the button finish. What's going to happen now is that there's going to be a replication happening. So that's what you see, that the configuration is happening. And if I hit the refresh button, we do see that now there is this workload, which is now getting configured. And the replication is kind of taking place under the hood. So if I hit the refresh button, typically it takes around 1 to 2 minutes in my testing environment, but you'll probably see that the configuration status is going to change and it's going to get connected to as OK. Once I see the button OK, I probably would be able to be secure because my VM will be protected fully. If I hit the refresh button again, okay, so it's still in configuration stage. What we can do is we can go and look at the other side in vCenter 2 and see if there is a replication happening on that end. So if I go to the Site Recovery Manager, and if I open the other site, which is the Site Recovery of vCenter 2, so you'll see that there's an incoming replication happening in vCenter 2. So if I click on this, in the incoming direction from VC1 to VC2, we see that it's in the configuring status. So let's go and hit the refresh button now. So yeah, as I said, it takes a couple of minutes because under the hood, it is talking between the two environments. It's copying all those details around the memory pages, the disk format. it is actually syncing the VM among the two environments. If I look at the VC1, I probably will see the outgoing direction because we are performing this SRM in the outgoing direction from the VC1 side and nothing in the incoming. Versus if I go to the VC2, I have it in the incoming direction, but nothing in the outgoing direction, just because we are performing one-way SRM between the two vCenters. So it's showing not active right now, and let me hit the fresh button. So it's now performing the initial sync. So this is where your SRM is getting replicated. A lot of information, SRM specific protocols are taking place under the hood. And in a matter of few moments, it should be completely synced between the two environments. So yeah, as I said, it takes a couple of minutes, but now at this point, my virtual machines has been completely replicated among the two environments. So if I go to the destination side, which is VC2, and I hit the button refresh, I'll probably see the status is okay. And imagine in this situation that my VC1 for some reason has gone down. So in this case, if I don't have access to the workload in vCenter 1, I can quickly jump onto vCenter 2, hit the button, and I can click the button sync. When I press the sync button, it's going to capture all the latest information that it has access to. And typically you'll do that because if your RTO, RPO timings are more than 24 hours, but probably you want to capture any latest information. So you hit that. Once you click on it, you can hit the button recover. It's going to ask you synchronize recent changes or use available data. I'm going to just hit the synchronize recent because we just did the sync. And when the moment you synchronize, it gives you a warning message. So when I hit the next button, I have to select the folder where I'm intending to put this workload. And I have to select the host. So in my local cluster, I'm going to select the host 152, 153 in this case, just because the data store is common. And if I hit the button finish, what will happen now is that now VMware is going to make sure that it creates the copy and it's going to spin it up in the new vCenter. So in a matter of few milliseconds, you did see that the VM has been completely recovered in vCenter 2. So if I go back to my host environment, we'll see that the D2 VM is still there, probably because I have not actually turned down the VM. But what is critical is that I have a copy which is running in the vCenter 2. So now that same VM has completely migrated because of the replication that was happening under the hood. If I click on this VM, we'll probably see that the VM is up. And everything is operational. The VM has fully recovered. So if the situation was catastrophe where your vCenter 1 was dead, you would not be worried because the workloads in that vCenter were completely protected. With that, I'm going to go quickly to my demo 3, which is where we're going to leverage the GCVE environment. So before I go and run any demo 3, 4, and 5, I want to take a quick moment and I want to show you how Google Cloud VMware Engine is set up. So when you log into a Google Cloud platform, I have projects. I have a hub project, and I've got two environments. I've got a demo, and I've got a non-prod project. I'm going to just pick one cloud at this point, which is paired in my demo project. And once you have your GCVE set up, you can literally go into the hamburger menu on top left, click on VMware Engine. Once you click on VMware Engine, what's going to happen is that a new dashboard is going to open, which is where Google is hosting all of your VMware software data center within Google Cloud. What comes out of the GCV product is basically a basic 5 softwares. You get the HCX, the vCenter, the ESXi nodes, you get the NSX controller, and you get something called vSAN. So in the summary page, it's going to show you all the relevant information around your cluster. So I've got a node 3 node cluster. My environment name is GCV production. It's an operation status. It's running in USCS 4. If I go to my vSphere management networks, I've got these FQDNs, which I have configured and I've integrated using DNS configuration. So in my on-premise environment, I've got an on-premise DNS where I'm actually using conditional forwarder to resolve the gve.goog domain. And then what I'm doing is on my on-premise environments, I have the forwarding zones and reverse zone all set up so that my on-premise workloads or on-premise management nodes, which includes this laptop, can resolve these vCenters, NSX, and HCX. So I'm going to click on the vCenter, and with that, I can launch this portal, and it's going to give me a dashboard, which is, so I'm already logged in. So I'm going to show you this login page. So it's running in vCenter in US East 4 region. And as you can see, I've got the exact same environment. I've got 3 nodes, 3 SXI nodes, and the environment is spin up. I can use to host workloads in this environment. If I go back, I can actually spin up the NSX cloud to see how the NSX is operational in this case. So let me log into the NSX to show you how NSX works. So if I log into the NSX environment, it's basically already pre-configured because the idea is that the customers do not want to take the hassle of managing the NSX segments, the networking tiers, and there's a lot of functionality that is all spin up with few clicks. So you get the NSX controller fully operational with the licenses when you spin up the GCV cloud. So let's go back to the demo and start to look at the third demo where I want to show you as to how you can configure vMotion using VMware HCX. So if I show you the GCV cloud, I have not showed you how the HCX is set up. And this is where this slide was relevant, that typically when you spin up your GCV cloud, you do get a dashboard which hosts all the software tools, which is in summary page. What you can do is you can quickly look into this page where you have the small download button and a license information. You can actually download the license and the OVA file, which you will spin up on your on-premise environment, which is what I've done, which is known as VMware HCX connector. When you click on this HCX connector, or when you install the HCX connector, you have to log out and log in to your on-premise dashboard, and you will see an HCX plugin getting installed in your on-premise vCenter. When you click on the HCX on-premise center, the first thing that you'll see is a landing dashboard. Once you install the HCX, what you need to do is first and foremost, you need to start looking at your VMs, and you need to start looking at your setup as to how you're going to set the site pairing. So the first thing that you'll do is you need to install the HCX OVA. You need to establish your site pairing. Once your site pairing is up, you can then start to configure something called service mesh. So once you install the service mesh, or once you configure the service mesh, basically the idea is that you create a compute profile, a network profile, and then you configure something called service mesh. So in my home lab environment, I have the interconnect, which is what the service mesh is all about. I configured a compute profile, I have a network profile, and then I create the service mesh, which is actually ties in the two profiles together to have the end-to-end service mesh established. It's not the Anthos service mesh or not the Istio service mesh. It's completely a service mesh keyword within VMware architecture. Once you set up, so this is the same slide that I talked to you about. You create the firewall rules, you create the FQDN resolutions, you configure the licensing and the site pairing, you create the network and compute profile and the service mesh, and then you install something called network extensions to initiate the H6 operations. So without further ado, I want to quickly show you the demos in terms of making sure that we perform the H6 vMotion, leveraging the HCX technology. So one thing that I want to show you is once you have your end-to-end set up, you'll see that the H6 Advanced gives you the hybrid interconnect service, the WAN optimization service, cross-cloud vMotion migration, and bulk migration service. Another thing is the network extension, which is what you're going to get in the fourth demo. Once you have your site pairing up and your service mesh established, you can quickly go to network extension, or perhaps you can go to migration, and you start to look at how you're going to start to plan your migrations. So the first thing you need to do is you need to select the migration keyword. What's going to happen now is that you're going to see that you have a source site and a destination site. On top, you'll see the source site, which is HCX connector on-premise. That's basically my OVA file installed on my on-premise vCenter. The destination is basically US East 4 HCX hosting in Google Cloud. So what I want to do is I want to click on a candidate VM, which is my Demo 3 HCX vMotion VM, and I want to select Add. Once I select that VM as a candidate, I need to configure some of the configurations. So this is a compute container. Where do I intend to move this VM using HCX vMotion? I want to put the data center cluster, storage, I want to select the vSAN data store, migration profile, and you see two options, vMotion, bulk migration. For this migration, I'm going to select vMotion. Destination folder, I'm going to select workload VMs. Disk format, you can select thin provisioning. Switch over profile, this is completely optional. If you want to migrate the VM at a certain schedule, you can define that. Otherwise, you can ignore this for the purpose of demo, and you can do this immediately. Another thing which is important is to make sure that you're defining your destination network. So in this case, because we have NSX and we have the segments created, I have a segment called prod segment where I have an IP address and DHCP server running with the pool 10.140.0.254. So I want to go back and I want to connect this NSX segment prod to this VM. Once this VM is going to spin up in the GCP cloud. Once you set that button, you can click the button validate. And with the validation, if all the configurations are in order, you should see a successful validation. Before I hit the button go, I want to quickly go back to the on-premise environment and let's do a duplicate here. And let's go to the VMs to quickly show you a few things. So this is the demo 3. I want to quickly jump into this VM. And I want to show you something very important. So when we look at the VM running on premise, what we see is that this VM is operational and it has an IP address and a MAC address, the IP address being 68.224 and the MAC address being 5B59. And what I want to show you here is basically you will be having this virtual machine running on premise because it's hot migrations. That means there should not be any downtime. So if your workload is running as is, what is really critical is that once you're migrating these VMs, you need to think about how the network connectivity is going to work through. So as I said, on premise, I have a 192.168 pool, but I do not have the same pool on GCP Cloud. On my GCP Cloud, I have an NSX, which is actually a 10.140 pool. So that means there has to be the whole concept of re-IPing the VM. This is where your firewall rules, your CIDR planning, all of that's going to be really critical in terms of your planning process. But there are use cases where customer want to change the IP space, IP schema, so you need to be mindful of that. So I have the VM running, it's actually production traffic, and now we have validated, and I'm going to hit the button go. The moment I hit the button go, you'll see that there are going to be a few things. So once you start the vMotion using HCS technology, it starts to create the virtual disks. It starts to create the base sync between the two environments. It starts to copy the memory pages. And it refreshes the data by actually refreshing the VM storage information and also host storage system. So all of those things are happening under the hood. And I have seen in my home lab that it takes around 4 to 6 minutes. So I want to quickly set that expectation because I have a limited throughput. And typically in a production environment, you'll have different NICs. You'll have a dedicated NIC for your vMotion, a dedicated NIC for your management network. Just because it's a dummy environment, I do not have a luxury of having multiple NICs in my home lab. So I'm running everything as is. I have purposely chosen a small site of the VM, but basically you do see the status getting updated here. So we started this migration at 7:09, and if I quickly hit the button refresh, we'll probably see that this migration should be cutting over from on-premise to GCVE in a matter of next couple of minutes. So you can actually see the current status on the GCVE side. So let's go to the GCVE side and see what do we see on the GCVE side. And before that, the traffic is still going through. This is a snapshot of the H6 vMotion's workload, which is actually running traffic. And this is again home lab. It's still in progress. If I hit the button refresh, I do see some of the migration steps happening. But if I go to the Google side, and if I say that I want to check the status, HCX status on the destination side, and let's go here, you do see that there is one VM migration in progress. We have the site connect as I showed you earlier. This is my Ashburn site, which is GCP Cloud, and this is a local home lab, which is running in Toronto, which is my home lab environment. So if I go to the migration page, and what you see now is that the base sync is now started to happen. And you see that status is getting updated here. So the vMotion is taking place. Your migration is happening between the HCX sitting on premise and the HCX sitting on Google Cloud. Now you do see that the copying of virtual machine is taking place. So this is where your traffic might be disrupted if you have not planned the network connectivity. So I still see the traffic going through. Just because it is a hot migration, the VM never goes down. It's up throughout its entire life cycle of migration. But if you go to the Google side, this is where a lot of things are common to understand. Number one is how much bandwidth and throughput you have. What is the size of the virtual machine? The bigger the virtual machine, the higher the migration timeline. And the bigger the throughput, the faster the process is. So it's very critical to understand how and when do you plan your wave migrations. If you have critical VMs that you want to migrate, make sure that there's no congestion on the network. So perhaps you might be picking later time in the day where you don't have much of operations. You may want to tweak your environment in a way that you're actually giving maximum throughput to the connection. And you want to keep in consideration those things. So what we did see during I was giving explanation is that the relocate virtual machine has happened. So the way to quickly check that is basically going into the public cloud and quickly checking over on the vCenter on the GCP side. So let's go quickly. Well, right now you can see that it's still showing the base synchronization happening between the two environments. And but we can go quickly and check the status of the VMs on the GCP side. What we do see is that the demo 3 HCX vMotion app is actually, or the workload is actually migrated. So if we come here, this is the output of the same VM on premise. We do see that the connection to console is turned down just because see the connection is local to vCenter. But if you come to the Google Cloud vCenter and you click on the same VM machine, you will see that it is showing you the same output. However, because the vMotion nature is to retain the IP address and the MAC address. However, we do not have the network extension. We have a completely different IP pool from NSX. So what we would need to do is we need to give a restart, or rather service. Okay, so service network restart. So once I restart the network service on this particular VM, if I quickly check the IP address, so we had the 192.168.62.224, which is the IP address and the MAC address on the VM when it was on premise. Now I have restarted, so the NSX component would have given a new IP allocation. So what you see is that the 10.140 subnet is now actually available for. So now the NSX is actually running the DHCP server and it's actually talking. So you didn't see the network downtime or the VM downtime, but the network planning is really critical in terms of understanding as to how that's going to happen. So that's something to be mindful of. Okay, so we did the demo 3, which is the hot migration of a VM using HCX vMotion. So let's quickly jump on to how we can avoid this case where we have to migrate the VM and we do not, or we cannot afford to actually go into a hub cycle on the network connection. Well, to address that problem, VMware has something called network extension, which is basically you can have the layer 2 extension among the two environments. You can actually choose the VMs to move from site 1 to site 2, maintaining the same layer 2 MAC address, same IP address, yet not losing the network connectivity. Well, the first question that comes to mind is, where's the gateway going to reside? So you have a choice of keeping the gateway continue to use on-prem versus moving the gateway as well. NSX has that control that can be offered with HCX. So let me quickly show you the demo 4. So there are a few prerequisites. You need to have the tagged traffic. You cannot move a VM without, or you cannot move the network extension with untagged traffic. So you need to have that isolation. And that makes sense because if you are moving across many of the VLANs, you want to make sure that that isolation of the traffic within a subnet is maintained. So tagging is important. In terms of stretching the layer 2 segment, there are two options available, the VDS, which is a virtual distributed port group, and the NSX. For any customers who have NSX on-prem, they'll probably use NSX overlay. For any customer who's not using NSX on-prem, they can have vSphere standard license to create a virtual distributed port group and extend the VLAN tag between the two environments. So the way I have done this test is basically I have a dedicated cluster with two machines, D4 L201, that's demo for layer 2 machine 1, demo for layer 2 machine 2. So what I've done here is basically two virtual machines sitting on the same VLAN 100. So I'm going to quickly log into these machines individually. So if I go to the first machine, and if I want to show you the IP address on this machine, so we have 192.168.121. And if I go to the second node, which is L2, so it's 192.168.122. These two are on a dedicated VLAN 100. So I can actually ping the two machines across each other. So 22 is the workload 2. It's pinging 21, which is workload 1. So as you can see, there's connectivity. And vice versa, I can ping 22, which is workload 2. So we do have bidirectional ping between the two machines because they're sitting on the same VLAN. What I really want to show you now is by extending one of the workloads, if I want to move the machine 2 to GCVE, yet maintaining its MAC and IP address, yet maintaining its connectivity back to on-premise. So the way you would do that is basically by going onto your GCVE cloud, in fact, going onto your HCX portfolio and something called network extension. So as I said, I created a network extension for VLAN 100. So basically you set the network extension up between your HCX on-premise and your HCX running on GCVE cloud. And what you would notice is that I have a distributed port group with a VLAN 100. I have a dedicated subnet, which is 192.168.100/24. Basically, this is a dummy VLAN. I do not have a separate gateway, so I don't have a gateway. However, I have two hosts within a distributed port group. I have extended this network end-to-end between the two environments. So if I go to the migration methodology now, and this is the first HCXB motion we did, if I go and if I continue to follow the same process of migrating the layer 2 workload, so this time, as I said, I'm going to continue to use the L201 on-premise, and I'm only going to stretch the L202 as a candidate. So I'm going to add that, and I'm going to follow the same process, picking the cluster. Storage is going to be vSAN data store. Profile this time, again, is vMotion. Destination folder, I can pick workload VMs. And then thin provisioning. That's basically just to minimize the time of migration. I'm not scheduling anything, and I want to say apply. What is really important here to notice is that this time, because this two workload are tied to a distributed port group, which is common with network extension, you'll see that here I do not need to select any network. You do see a predefined network adapter, which is L2E underscore and then the name of the port group. So we'll keep this as is, and we're going to hit the button validate. And I'm going to walk you through while it gets migrated. So once you hit the button go, what's going to happen is now the migration is happening, similar concept, but at this time the difference is it's using network extension, which means that now we would not need to go through that network hub cycle to get the new IP allocation. We do not need to worry about the re-IPing of the workload, and we can actually continue to use the same MAC and IP address with no traffic downtime. So if I go to L202, it's still pinging L201 on IP21. And if I go to L201, it's still pinging 22, which is the workload number 2. But what is really important is that we want to go to NSX, and we want to click on the NSX segments. So when you click on the NSX segments, once you create the network extensions, you'll probably see a few segments getting auto-created. So this is the first segment, and this is the other segment. So we can ignore this one. That's not the correct one. This is from the testing environment. But you look at the L2E destination distributed port group 100. That's the port group that got created with an IP address 192.168.100.1. That's the network extension that is stretched among the two HCX endpoints. And if I want to go to my T1 gateway, it is not only using one linked segment, but it also has another linked segment, which is where your new VM, which is going to be migrated to GCVE, is still going to be using the network extension to transport on the layer 2 segment stretch between HCX on cloud and HCX on-prem. So let's go back to the ping and see if the pings are going through. I still see the workload 2 is talking to workload 1. If I want to go to workload 1, I see the traffic is going back and forth. Let's see what's happening on the HCX page. So in this case, if I perform a refresh button, I see that the migration has started. But as I said, it takes few minutes just because it's a slow process in my home lab, but you get the idea. If I go to the on-premise environment, we have selected the one of the VMs. We are moving the demo for L202, so it's still on-premise. And if I will go to the on-premise HCX, now we see that there's, again, the same process of refreshing VM storage information, refreshing the host storage system, performing the base synchronization, and then the relocation of the VM. It is copying over the memory pages. So now you see that the status has changed from migration started to vMotion transfer in progress. So something to be mindful of, that it is similar to how we saw the last migration. The only difference this time is that the network extension is being used, and this is where your layer 2 subnet is stretched. If you go to the dashboard, we'll see that it will say the migration is in progress. So you'll see that one of the VMs is still in progress. We have one network extension. We have a site pairing, which is up. And among the site pairings, I've got site pairing, which is established, interconnect. They've got two interconnects, as I said. The first interconnect, I established it with one host. So I had these 4 servers. On the other interconnect, I have a network extension interconnect where I have extended the network extension service. Again, this is running between Toronto, my home lab, and a remote profile. So now you can see the status is changing for only the workload number 2, which is where the workload 2 is migrating and cutting over from on-premise to GCVE. So again, dependent upon few factors, throughput, size of the VM, but what is important to understand is that we should not see a downtime. What we will see is that the console connection will be terminated, which is understandably right, but the ping should go through seamlessly. And what I want to show you quickly now is on my home lab, which is the vCenter 1, vCenter 2, I do not see the workload number 2. So my understanding is that that workload has moved off completely without any disruption of the traffic into GCVE. So if I click on the layer 2 workload now, and if I want to show the console, I should see the ping going through end to end. And this is exactly what we see. There is no packet drop. It maintained the IP address and the MAC address. So if I want to quickly stop the ping, we see 399 packets, 0% packet loss. And if I go here and if I stop this, we see 397 packet with 1% packet loss. In ideal situation, there should never be any packet loss. Well, total for 3 packets, 397, but basically you should not see any packet losses. It is just a congestion on my end, and that's perhaps a surprise, but generally there's no packet loss. So that takes care of our network extension at layer 2, and I want to be mindful of the time here. So let's quickly jump onto the last demo, which is, so we just did the network extension, stretching the layer 2. And the last one is bulk migration via VMware HCX. It is the same migration methodology, but imagine a use case where a customer have hundreds and thousands of VMs. So if a customer has 500 VMs or 1,000 VMs, it's really, really important to understand as to how the customer is going to be migrating them. There has to be some automation around it. So what VMware offers, or GCVE offers with VMware, is an option of bulk migration. So once you select the source site, basically you can pick 2 candidate VMs. You can have more than one or one as a bulk migration. But basically what I'm going to do now real quick is I'm going to perform a similar practice of migration. So we have the demo 4 and demo 3 completed. I want to quickly start the demo 5. So in this case, I'm going to select 2 VMs and perform a bulk migration. The process is the same. I'm going to select the two candidate VMs. I'm going to add them into my scheduling, select the container, which is the cluster on premise on GCVE. Storage is vSAN data store. Migration profile this time, I'm going to select bulk migration. Destination folder is, I can select the workload VMs or any other folder. Thin provisioning, and the switchover profile, I'm going to skip and I'm going to apply. Something that is really important is that you need to select the destination network. Again, I have an NSX segment, which is prod segment 1. I'm going to select that. And for my second VM, I'm going to follow the same process. And I'm going to selection apply and destination network. Again, the NSX logical segment, prod segment, select. If I run the validate button, I probably will see a small error. And that error is talking about the VMware tools, something which is missing on my on-premise because of license limitations. However, with the bulk migration, what happens is that the idea is the same, that if you have a data center collapse, which is similar to how the SRM works, so the replication methodology, so it will go through power off of the VM because it's a warm migration, it's not hot migration. So what I'm doing now is I'm selecting the force power off and I'm going to hit the validate button. And this time the validation is going to go through and I'm going to hit the button go. So once I do that, I've got bulk migration of the two VMs set up. And as you see, that migration started is basically the first step. If I go to the on-premise, I'll probably see that the two VMs, which are the bulk migration demo 5 VM01 and VM02, I can quickly log into these machines. These are small, tiny VMs running the connectivity to their on-premise gateways, 226. And I've got the bulk migration VM2. Running an IP address 226. So if I want to ping, these are again two workloads talking to each other on the same LAN. They can talk to the gateway. And so I'm running these as is. And with bulk migration, the idea is that the VMware shuts down, the replication starts to happen, and then it spins up in the destination site. So this again takes around 4 minutes, or sometimes 4 to 8 minutes, but you get the idea. So what I'm going to do now is I'm going to quickly pause this video, and I'm going to come back once it's completed. Currently, right now, it's 7:33 on 30 seconds. I started this off at 7:27. So as I said, it took around 6 minutes for the VMs to migrate. I have the two sessions that were open, but they both are disconnected just because if I go to the source site, the two VMs are powered off. So as I said, the replication is the first thing that happens under the hood. The VMs gets replicated and then it gets powered off. So we do see that the VMs are powered off on the source site, and that's why we don't have these serial connections up. We do see that it's migrating off from the vCenter 2 to Google Cloud. If I go to the destination site, we do see that now it's coming in from vCenter 2 to the Google Cloud GCVE environment. And if I go to the vSphere in Google Cloud, we see that these machines are powered off because the replication is still ongoing. But after the vSphere migration is completed, we can turn on these VMs and the VMs will have the same data that we had as on-prem. Again, the network connectivity of these VMs were tied to the environment that we had on premise. So we need to take that factor into mind, and this is more switchover. So you can do this for hundreds of VMs. You can do this based on the scheduling of the VMs, but you get the idea as to how you can select more than one VM as part of the bulk migration profile. So if I refresh the button, the migration will continue. And we now see that on the Google Cloud, we have these VMs up and running. And if I click on these VMs, if I go to console, I'm just going to pick one VM at this stage. So yeah, so you get the idea. We are actually up on the VM in Google Cloud. Now it has picked the new IP address. It is now working within GCP Cloud. So if I want to ping I guess it's 254. Yeah. So we can do the same on the second product, which is what we can see, but basically you get the idea. And yeah, it takes some time to update, but basically we do see that the VM has migrated. There are some other, cleanup processes that are going through. Um, so yeah, that's something that the customers will choose if they have a lot of VMs to migrate and they want to schedule certain waves accordingly. So with that, the demo 5 is completed. And so at Sada, what we are doing is we are helping our customers solve the complex process of not thinking out too loud, but understanding as to how the journey can be simplified, how VMware and GCVE specifically can make that whole migration journey seamless in terms of getting rid of their expensive licenses, getting rid of their capacity planning on premise, getting rid of the setting up disaster recovery sites, the whole hardware refresh cycles. So the whole process is baked in with a matter of few clicks. You can leverage those migration processes. Very simple. You have got more than 5 options to choose from in terms of which migration strategy would work for you. At Sada, we have delivered dozens of these migrations for very large customers, and they are extremely happy in terms of their migration. Sada has tools, Sada has a solution catalog, Sada has Terraform codes in helping customers move off from on-premise to Google Cloud in a matter of days, if not weeks, or weeks, if not months, depending upon the size of the on-premise data center. We use Terraform for setting up the environments, and we have solution catalog, as I mentioned. I'm happy to answer any questions. I hope this was helpful. Please take a note of my email address. I'll be happy to answer any questions. So feel free to drop me an email, and I look forward to you with your complex problems that we can solve at Sada. Thank you.